is defined by 2 points. Point P is 2, 3 and point Q is 5, 5. Can we find the equation of the line? Okay, let's do this the same way we did before in lesson 1. We have our graph and we have our X and we have our Y. But this time I want to do something slightly different to introduce you to a new set of terminology, and this time instead of Y I'm going to say this is f of x. For the moment just read f of x as y, and we'll look at what f of x is in a little bit. So we have our line and we have our rise over run to get our slope. Only this time, instead of saying delta y, we're saying delta f of x. So this is the change in f of x with respect to x. And this is the delta x, which is the change in x. Okay, so let's plug in some values. So delta f of x, which is our change in f of x, is equal to, and let's say it's gone from 3 to 5, so that's 5 minus 3, and we're dividing this by our change in x, and that's gone from 2 to 5, so it's 5 minus 2. So that's equal to 5 minus 3 is 2, and 5 minus 2 is 3. So f of x is equal to 2, the slope is 2/3, and then we have our it's our y-intercept, but now it's our f of x intercept. Again, to find out what it is, we just plug in our numbers. Bear in mind these points are no longer x and y, they're x, comma f of x. So f of x is equal to 3 when x is equal to 2. So 3 is equal to 2/3 x plus, we don't say x because we know what x is. X is 2. And that's plus c. Okay, well 2/3 times 2 is 4 over 3. So 3 is equal to 4 over 3 plus c. So 3 minus 4 over 3 is equal to c. Well, we can think of 3 as 9 over 3, because 9 divided by 3 is 3, and then minus 4 over 3 is equal to c. So c is equal to 9 minus 4 all divided by 3, which is 5 over 3. Okay, so we can define f of x as equal to the slope, which is 2 over 3 times x plus our intercept, which is 5 over 3. Okay, so why are we using this f of x notation instead of normal y notation? Well, it's because I want to be difficult. No, not really. It's just good shorthand, and we're going to use this a lot in calculus. And also, I think it's a little bit more powerful than your normal y equals notation. Right, so we had f of x is equal to 2/3 x plus 5 over 3. Okay. Alright, so what can we do with this function notation that we can't do with just regular variable notation? Well, first of all, what is function notation? You've seen functions before. You've seen like sine theta is equal to opposite over adjacent, yeah? You might have seen other functions as well, like tan theta. Or you might have seen log x. Or the natural log of x. And of course you'll have seen cos theta. I'm just trying to think of functions that you might have seen. Okay, so with these functions, this is the name of the function. And this here is the argument. No, it isn't. Yes, it is. No, it isn't. And I can't write, can I? Okay, so what's an argument? No, it's not when you're disagreeing with yourself like I am. It's the variable that is passed to the function so that the function can do something clever with the variable. And what does the function do with the variable? Well, it depends on what we've defined the function to be. In this case, if we pass the variable x to f of x, then it will take the x, multiply it by 2, divide it by 3, and then add 5 over 3 to the result. So let's give that a try. So let's pass the argument f of 2 to this function. We know that the 2 here should come out as 3. If we did this correct, we will get 3 as our result. So f of 2 is equal to, so what we do, we write out our function definition, but instead of x, we replace it with whatever x is, which is shown in the brackets. So this is 2 over 3 times 2 plus 5 over 3. Well, that's equal to 4 over 3 plus 5 over 3, which is equal to 9 over 3, which is of course equal to 3. So when x is 2, f of x equals 3, which is as we would expect. And we can do the same with f of 5. Which is equal to 2 over 3 times 5 plus 5 over 3. And that's equal to 2 times 5 is 10, so that's 10 over 3 plus 5 over 3, which is equal to 15 over 3, which is equal to 5. And that's what we were hoping it would be. Okay, so besides passing arguments to the functions, what we can also do with functions is to nest them. So we could have a function as the argument for another function. So let's let f of x equal, let's say 2x plus 1. And let's let g of x, you can have anything you like as the name of the function. G of x, you can also have any variable you like as the argument, is equal to, let's say, x squared. Okay, so what is f of g of x? We're now passing g of x, which is a function, into a function. Okay, so we write out our function f of x, which is 2x plus 1, but instead of writing x, we write whatever's in the brackets, which in this case is g of x. And we know what g of x is equal to. It's equal to x squared. So that's 2x squared plus 1. We could nest them the other way around if we wanted. We could ask what is g of f of x. Well, that, we write out our function g of x, which we know is x squared, but instead of writing x, we write whatever's in the brackets, so that's f of x squared. And we know f of x is equal to 2x plus 1, so that's 2x plus 1 squared. Okay, so that's one clever thing we can do with functions. We can nest them. The other thing is we can find the inverse of a function. So let's just arbitrarily create a function. Actually, we can get rid of all this now. Okay, let's create f of x is equal to 3x plus 2. Just made that up off the top of my head. And what we want to do is find the inverse of that function. Now we write the inverse of the function as f to the negative 1 of x. Now I should point out that's not the same as the reciprocal of f of x, for those who are familiar with the reciprocal as x to the minus 1 is equal to 1 over x. But this is not what we're doing. The reciprocal of f of x would be f of x to the power minus 1. But that's not the same as f to the minus 1 of x, which is the inverse of f of x. And what's the inverse? Well, the inverse of f of x is that which, if we plug f of x into the inverse, we will get x out. In other words, f to the minus 1 of f of x is equal to x. That's our definition of our inverse. So we're looking for a function that if we plug f of x into that function, we will get x out. Okay, well, one way we can do that is if we go back to our y notation just for simplicity. So let's say y is equal to 3x minus 2. Sorry, 3x plus 2. And then we want to solve for x. We can take the 2 across, so it's going to change sign. So y minus 2 is equal to 3x. And then divide by 3. So y minus 2 over 3 is equal to x. And then we replace the y by our f of x, or our we'll replace y with x, and we replace x with our inverse of f of x. That's a tongue twister. Right, so this is what I'm doing. I'm taking that y and I'm saying that's x minus 2 over 3 is equal to f to the minus 1 of x. That's what I'm trying to say, if I can get my tongue back in my mouth. Alright, let's see if that's correct. Let's just get rid of our working. So we go back to our definition of f to the minus 1 of x, or the inverse of f of x. So if we nest f of x into this, we should get x back. So what I'm saying is f to the minus 1 of 3x plus 2, which is our f of x. Now I'm saying that that is going to come out to x. Well, let's try it, shall we? F to the minus 1 of x is x minus 2 over 3. So that's equal to x, which is whatever's in this brackets, which is 3x plus 2. And then we're subtracting 2. And then we're dividing the whole lot by 3. Okay, well, plus 2 and minus 2 cancel out, and the 3's cancel out, and we're left with x, which is exactly what we were hoping for as the inverse of f of x. So that's something else we can do with functions. We can find the inverse of the function. Okay, I think we've covered enough for functions for this lesson. Let's work through a few questions and see how we get on. Okay, so we've got 5 questions here. By the time we get through all 5, we should be fairly confident with what we're doing, I hope. Okay, so f of x is equal to 3x and g of x is equal to x squared. Those are our definitions of our functions. So part 1 is asking what is f of g of x and what is g of f of x. That's 2 questions in one. That's cheating. There's not 5, there's 6 questions. Okay, so what is f of g of x? Alright. So we remember f of x. That x is terrible, but I'm not going to correct it. When you see that actually means an x. Okay, so f of x is equal to 3x. That's better. That's a much better x. Okay, so f of x is equal to 3x. And we know our g of x is equal to x squared. So f of x, or f of g of x, is equal to f of g of x. But g of x is x squared. So this is f of x squared. Oh, now my x is even worse. Okay, never mind. Alright, so that's pretending to be an x. Okay, so we've got f of mess squared, which is equal to, so what's f of x? F of x is equal to 3x. So we write down the 3, and where we write x, we look in the brackets of f to see what should be instead of our x. So this is x squared. Okay, so f of g of x is equal to 3x squared. There, we got it. We got through it. Okay. With some terrible handwriting, which I am now going to erase all the evidence of. Can't prove it. There you go. I didn't do it. No one saw me do it. You can't prove it. Okay. G of f of x. So Again, we know f of x is equal to 3x, and g of x is equal to x squared. Okay, let's just move this out the way, and I'm going to call this I, or Roman numeral 1, and I'm going to say that g of f of x is equal to g of, and f of x is equal to 3x, and of course g of x is equal to x squared, so we write down the x, but instead of x it's 3x, because that's what's in the argument of the function, so it's 3x all squared, which I suppose if we wanted to expand that out, we would say that's 9x squared. So that's part 1 done. Okay, so part 2. What is f of 3? Okay, well f of x is equal to 3x, so f of 3 is equal to 3 times 3, which is equal to 9. Okay, let's try part 3. What is g of 4? Okay, so g of 4 is equal to, g of x is x squared, so g of 4 is equal to 4 squared, which is equal to 16. Okay, so let's do part 4. What is f of g of 4? Well, we don't need to do much with this because we already know that g of 4 is 16. So this is equal to f of 16, which is equal to, and f of x is equal to 3x, so that's equal to 3 times 16, which is equal to, 3 times 6 is 18, and 3 times 10 is 30. 30 plus 18 is equal to 48. Okay, and part 5. What is g of f of 3? Again, that's been very nice, because we already know what f of 3 is from part 2. F of 3 is 9, so we're really asking what is g of 9? And g is x squared, so we're asking what is 9 squared, and we know from our times tables that that's 9 times 9, which is 81. And that is all there is to it. Okay, I hope that was helpful, and I'll look forward to seeing you in the next lesson.